Alright, hello everyone. Welcome back to part 2 of the Quiz Plus study guide. Today we're going to be, or now, whatever, we're going to be doing the practice problems. So, I'm going to tell first few things. So, I'm pretty explicit with these practice problems, like, if they're going to be on the test. This first problem right here, this chart, this is on the test. This is the entire basis of this Quiz Plus. So, if you mess this chart up, then you're kind of in some trouble. This is going to be on the Quiz Plus. This exact chart right here. Again, like this one right here. Question 1. You're going to see this exact same thing. Easiest 6 points you'll probably earn. Mass of a proton, 1 Dalton. Mass of a neutron, 1 Dalton. Mass of the electron, 0. Our charge of a proton, +1. No charge on the neutron, -1 on the electron. This right here, you're going to see a carbon copy of this question here. Question 2. I can guarantee you, 100%, this is going to be the same exact question on the Quiz Plus. These electron rings, right? How many electrons are in each of these rings is super, super important. Especially this outermost ring. But we need to get to the outermost ring. We have to figure out how many electrons are there. And during this class, we'll break down why there's certain amounts in each of these shells, and we're gonna change the way that we look at atoms because we've been representing them in this two-dimensional form. We're gonna change that, but this is a good basis to start as. Without keep going, I'm going to actually what I'm gonna do is I'm gonna copy this into Paint so I can easily draw it. So here is our atom, and I said that there are 19 electrons. So 19 electrons. This in the middle bit is the nucleus. So this is where all the protons and the neutrons are. So we're not going to deal with that. So if there are 19 electrons, the first ring always has 2. It can only have 2. 1, 2. So now we're down to 17 electrons after the first ring. The second ring can have, I need more fingers, 8. Where's my webcam? Here it is. 8. There we go. Got all 8 fingers on the camera. So 1, 2, 3, 4, 5, 6, 7, 8. So we now have 9 electrons left. Third ring can also only have 8. So 1, 2, 3, 4, 5, 6, 7, and 8. And we now have 1 electron left. So this is going to go into the last ring. Okay? So this has 19 electrons. You're going to have to know 2, then 8, then 8, and then we'll call it 8 for now. I'm not going to give you anything that's bigger than that because we'll see how it changes. But you got to know how many are in definitely these first 3 rings here. Okay? And this, so when I say, and you're going to see a question that's be like, how many electrons are in the outermost ring? The outermost ring would be just this 1 electron. 1 electron in the outermost ring. Alright, so I'm just going to create a new. Draw an atom with 4 protons, 4 electrons, and 5 neutrons. I give you the key here because, oh, I didn't want to do that, actually. I wanted to actually import that image into here, but that's okay. I can edit this, I think. Okay, hold on. Okay. So here again, I'm doing this kind of makeshift. Bear with me. I basically use these videos as a way to actually do the like the answers to the study guide, so it can kill two birds with one stone. So how's everyone's day doing while I get through all of this? Hope everyone is ready for this. Had a good weekend. You'll be seeing this video on. I might just post it on Monday. I said Tuesday, but I might change that. 6. Just because yeah, 4. What am I at? 1, 2, 3, 4, 5, 6. All right, here we go. So there's our answer. There's 8. There's 19 protons in there. And if there's not, then there should be. Okay. So right here, this is going to be your key. It doesn't let me. I have to manually do this. It doesn't. Whatever. So we had been drawing with different colors, but on a paper and pencil, you only gotta get your pen. So here's how we're gonna use. We're gonna use these little notifications. You can, if you really want to, you could use a different shape. You could do like a triangle for a proton. You could do like a circle for a neutron. And you could use like a square for an electron. As long as I know what each one of the three, like as long as you can tell me each one of them is this something, I don't really care. Okay? So 4 protons, 4 electrons, 5 neutrons. So our protons, I'm actually just going to use this because it's easier to draw in here. We got 4 protons. We got 5 neutrons. And we have 4 electrons. So this is the most simple. This is the simplest like question that you would have. Something like this. So I'm actually going to just put in all of this. Either key. So that when there we go. This is just an example of how I can do this with just one color. So get rid of that. Alright, so this is the simplest version of this. This is like where we really started out with. So this won't be worth that many points. I'll probably have something that's going to be this simple. This is to get you into that, are your protons and your neutrons and where they should be? Do you have the right amount of electrons in the rings? So that's why we need to know this. You need to know how many electrons are in each ring at a maximum. Now it's when we get a little bit more complicated. So let's create a... I'm actually going to use this same key here. And I'll tell you, you can use the same key throughout the rest of it. I'm just going to use this key just for simplicity's sake. So when I give you this chart to help you, right, you're going to get a chart like this. I do that. So I'm going to solve it here. We're going to be drawing this atom. So the first thing to know is when I give you a chart like this, you should fill it out with the information that you already have. Let's read through the question. We have 17 Daltons is our mass. Our charge is +3. Why is this? And we have 8 neutrons. So this should be enough information to solve the rest of this. For example, if our mass is 17, and we have mass is 17, we have 8 neutrons plus our protons. So we would subtract 8 from 17, and our protons would equal 9. 9 protons. So we can then answer, what element is this? Go to our periodic table. Something that has 9 protons. So 9 protons right here is always going to be fluorine. So this is fluorine, or F. This is the one with the answers. All right. Now, our charge is +3. We now know we have 9 protons. So that gives us 9 plus our electrons. That should be a... Oops. That's a 9. So we subtract 3. We have 3 minus 9 gives us -6, which, if you divide it by the charge of it, would give you 6 electrons. And because this is a plus, this is a positive ion, this would be a cation. All right, and then we can draw it. So what I'm going to do actually is I want to get this information here, post this, and then I'm going to draw this down here. So we have 8 neutrons, 6, 7, 8. We have 9 protons, 3, 4, 5, 6, 7, 8, 9, and we have 6 electrons. So 1, 2, 3, 4, 5, 6. So there is part 1 and part 2. This is all that I'm looking for here. So I'm going to post this into the document for you to see. So here is another example here. Okay. So I'm going to do the same thing. Same thing here. I'm actually going to make it a little bit bigger here. We're going to do the same exact thing. And I really should have copied over my scale here. So we are drawing 18F. So this is an atom of, well, we know that this is fluorine. That is the symbol for fluorine. So we already know fluorine is going to have 9 protons. Here's fluorine, 9 protons. And this number up here tells us that our mass is 18. Let's go back to the questions. Now, there is no charge here. This is missing. Because I don't explicitly tell that there's a charge. Where'd my webcam go? I'm hiding. Okay. Because we don't explicitly tell that there's a charge, that means our charge is 0. So, to get to mass, 18 minus 9 means there's 4 neutrons. Because the charge is 0, there's the same amount of protons and neutrons. And again, we can draw this in. 2, 3, 4, 5, 7, 8, 9. 1, 2, 3, 5, 6, 7, 8, 9. And now we have 9 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2. Yeah, I counted this right. All right. here is our answer to this. So I'm gonna get rid of this and put our answer key there. Alright, so let me paste this onto the next page. So the chemical formula right here, you calculate this by adding up all the different amounts of atoms. So we have, let's take how many carbon atoms we have. There are 1, 2, 3 carbon atoms. So here's carbon. We have 3 of them. I'm gonna do oxygen next. There's only 1 of them. 1 oxygen. And then 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So you could write it like this. You could write it like this. I'm not being picky on this because there's no way to expect you to have known this, like which order the letters go in. So I'm just gonna put it like this. Here we go. Nice and easy. All right. Okay. Write the chemical formula, chemical symbol for this atom. Include the mass and the charge. All right. So I'm going to move this out of the way. So this is a counting game. You should be able to count some of this stuff. So we have this information here is meant to help you. So I'm actually gonna it's here, chemical symbol. That's what our end goal is. So this is a counting game. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13 protons. I counted that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 neutrons. We count the electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electrons. So from here, our mass is equal to the protons plus neutrons, 27. Our charge, we have 13 protons. So 13 protons plus 10 electrons. So this is 13 plus a negative 10, which gives you a positive 3 charge, plus 3. And the element that this is, our protons is 13. Let's go to our periodic table, find number 13. This is aluminum. So this is an A. Excuse me. This is Al. This is an L, not an I. Aluminum. So our chemical symbol then, therefore, is going to be Al with a 3 plus charge and a mass of 27. So this is what I'm looking for, okay? I want the charge and I want the mass. Is there a way I can make this all on one page? There we go, perfect. All right, so that's what I'm looking for. Identifying what element it is, what the charge is, and what the mass is. So, how many electrons are in each of the following ions? So, you don't have to draw this out to get here. So, I'm going to basically copy this over. Oh, N3 minus. So, we know that nitrogen, right here, has 7 protons. Its atomic number is 7. Really doesn't want my webcam to stay here. So we know that we have 7 protons. Let me get back to this. So 7 protons. We know sodium always has 11 protons. And we know that oxygen is going to have 8 protons. Okay. So if there was a -3 charge, -3 equals 7 plus our electron charge. That gives us -10 is the charge of the electrons, so divided by -1, because each electron has a -1 charge, and you would get 10. Similar here, plus 1 equals 11 plus our electrons, so we get to -10 equals electrons, divide that by 1, we get 10. Again, right here, our charge is going to be -2 equals plus 8 charge. I really should be drawing in the plus 8s here to make this a little bit less confusing. Plus our electrons, which gives us, again, -10 divided by -1. So each one of these has 10 electrons. So these all have the same amount of electrons. Now, how many electrons are in the outermost ring? You could draw these out and figure that out, but I'm going to show you a nice little trick to do this. The first ring has to have 2, right? So if we have 10 total electrons and you subtract 2, that means that there are 8 left. The second ring can have a maximum of 8, so we fill that up. We're left with 0 leftover electrons. So the outermost ring, or each one of these, has 8 electrons in the outermost ring. And this is very important. Again, we're going to get to it, but it's important to know how many electrons are in that outermost ring. All right, problem 8. I'm saying this, you're going to see something just exactly like this. It's going to be different numbers, obviously, but you will see something like this on your quiz. You got to know, how do I do this? It was warm. I had a blanket on me. So, atomic symbol is B. And I say I didn't put in a charge here. So we know that our charge is automatically 0. I didn't write in the charge. I'm only going to be writing in the charge. I'm not going to be dealing with the mass numbers here. Okay? So for example, zinc here, I don't tell you what the mass is. You have to calculate that on your own. But I tell you that this has a +2 charge. Okay? So, protons. Boron, periodic table. Boron, atomic number 5, 5 protons. 5 protons, 6 neutrons, gives us a mass of 11. 5 plus 6. Charge is 0, so the protons and the electrons have to be the same. We get to 5. Second element. Protons is 12. Well, let's go. Right here, we know that this is 12. This is magnesium. So I'm going to put in Mg. I might have to change it for a charge. I don't know yet. Our mass is 24, and we have 12 protons. So 24 minus 12 gives us 12. Now, we have 12 protons, 10 electrons. I've been doing this math, repeatedly throughout this study guide. Right here, we have 12 protons, 10 electrons, gives us a +2 charge. So I'm actually going to go back here and write in, this is a 2+ ion. Third one right here. Tell us the charge is 0. So if the charge is 0, same amount of protons and electrons. Our mass is equal to neutrons plus the protons. So this is 68. And we have 31 protons. So let's look for number 31. Right here, this is gallium. All right, so let's write in gallium because there is no charge. We don't need to put in our ion. It is not an ion. All right, on to the next one. All we have is electrons and charge. So if we have 39 electrons, and we have -3 charge, that's enough information to let us fill in for protons. So -3 equals our protons plus our charge from our electrons is -39. So we do -3 plus 39, which equals 36. We have 36 protons. From here, our mass, 89, equals 36 plus our neutrons. So 89 minus 36, and you will have a calculator for your test. I'm not going to make you do this kind of mental math, or write it out. You can do this on a calculator, but this will give you 53 neutrons. This is not a stable atom here, but we have 36 as our protons. So let's look for number 36. Number 36 is krypton, Kr. But we have a -3 charge here. So we are going to -3 minus. This is one of those examples where this is not a real thing. I'm just having you do the math for the sake of it. This atom would not last very long. Say that. So back to here, zinc 2 plus. I already put in the charge as 2 plus as a +2. Zinc, go back to our periodic table, look for zinc. Right here, we know we have 30 protons. We know the protons, we know the neutrons, we add them up together, we get 65 as our mass. Just gonna scroll this over. We know that our charge is +2. So this equals to 30 plus our electrons. We have +30. So 2 minus 30 gives us -28. Is the electron charge. Divide that by the charge of 1 electron. Gives us 28 electrons. 8. Last but not least, we have 43 protons and a mass of 100. So 100 minus 43 equals, what's it, 57? So we have 57 neutrons. Our charge, we have 43 protons and 42 electrons. Here's from our protons, here's from our electrons. I'm just going to cross this out. This will give us a +1. Our charge is +1. We go back to our periodic table, look for element 43. This is technetium. So we go back, write Tc, and this would be plus. Technetium plus. Alright, that's how we do all this stuff. It's what we have been doing. This chart right here is all very similar to what I was doing here. Or what I was doing here. It's the same thing. Just, I'm not having you draw it all the time. So right here, translate the following secret message. This is just something I did for fun. I'm actually going to pull this out. So 74 is W. 89. Go down here. Oh, I actually forgot to... Oops. I'm going to add one in here. There should have been I'm missing a letter. Alright, bear with me here. Okay, got an H there. WH 89 is AC 6. Oh, that's what I messed up there. I'm gonna change your thing here. There we go. This is where I messed up. 19, element 19 right here. K, element 39 is Y. So when you see this on the study guide, it's gonna be fixed. This is a live reaction here. So our trans secret message is wacky. Yay. So for scholars and my regular class, that's all where we are gonna do for this this quiz plus. The following question is something that I went over just really explicitly with the honors class, just because we had that extra day to really go over this type of stuff. So if you're honors, keep watching. If you're not, then that's all, and you know, should be pretty thorough with this. All right. So here we're calculating the atomic weight of aspirin. So that is C9H8O4. I'm gonna make this a little bit bigger. There we go. So imagine you have an entire pill of aspirin, not a single molecule. If you had a single molecule, this is not enough information because you would need to know what's isotope of carbon, of hydrogen, and of oxygen you have. But we can take the average of. We can take the average. I'm gonna put this back in here. Of the elements or of the atomic weight. That's what our atomic weight is. So carbon is 12.011. So this is C. Hydrogen is going to be 1.008. And I think it's oxygen, right? Is 15.999. So to calculate this, calculate the average mass in Daltons of aspirin. You know, to have a whole pill, it's got, you know, trillions and trillions and trillions, and we'll figure out how many actually, but a ton of molecules of aspirin. So how do we do this? Should be able to see the calculator here. We're going to do this. 6. Right, it was 6. No, it was 9. 9 times this amount. 8 times this amount. And 4 times this amount. I'm going to add it all up. That. Okay. Times 4. Oh, we can calculate all this up, and this will give us. I'm gonna. This will give us 180.159 Daltons. So, if you were to add up the average mass, if you had an entire pill, you would get something that has a mass of, you know, you took the average weight, it would be 180.159 Daltons. There is no single atom or molecule of aspirin that has that mass. It all depends on what isotopes you have. If you have an isotope of carbon 13 or oxygen 17, that's going to increase the mass of that specific molecule of aspirin. But as we're going to see in this class, there's a ton of molecules. And I think I'm actually going to have, I think I'm going to do something a little spicy with our extra credit for the honors class, for this quiz plus. Just something a little fun. Um, But there's a whole bunch of stuff that you can do with this. You could figure out how much of this of the aspirin, the mass, comes from carbon, and we'll get into that. I believe later in this year. So I'm just gonna put this into our answer key right now. That's all for me. We're gonna I have some ideas for some of these questions. A lot of this test is going to be similar to this, because if you're still watching this, it's probably still in the honors. I'm going to spice up the quiz just a little bit more. Um, Add some stuff that you should be able to answer, even if I haven't explicitly taught you how to do it. What I mean by that is there are skills that you've learned throughout all of this that can teach you some stuff. Um, you know, Everything that I will ask of you, you should be able to do with the knowledge that you have, if that makes sense. But like I said, I like to challenge you, so I'm gonna pull some stops out. All right, so that's all for me. Enjoy the rest of your day. Whenever you're seeing this, I don't know when exactly it's gonna be. So that's all for me. Have a great rest of your day, everyone.